Oh, music is off. I guess that's our cue. Hello, everybody. Welcome to another session of Oasis. I don't know if we have a name for this series. It's definitely not Meet the Team, but it could have been because Peter is part of Oasis Labs, which we are very close with, but we will get into it in a second. I think we have an amazing topic today. I've seen lots of talk about verifiable AI on my Twitter feed recently, lots about verifiable inference, trustless agents, and also lots about ethical AI. And I'm sure we will get into all of this in a second. Before we start, this is, of course, a session where anyone can participate. Please ask questions in chat, in YouTube, on Twitter, wherever you kind of see the stream. I think there was even a form being sent out, and we are happy to pick those up. And I can ask Peter or answer myself, depending on what it is about. Okay, let's get into it. So we have Oasis Labs here. We have specifically Peter, Director of Engineering. So there is a bit of a differentiation. Like, I'm with Oasis Foundation. We are very focused on the on-chain stuff, on the actual blockchain, on our network, providing the infrastructure, all of the tooling, talking to the dApps that want to build. And Labs would be more on the enterprise side of things, building very cool privacy-preserving solutions with usage of some very big corporate names. But maybe, Peter, you can shine a bit more light on this. Who are you? Give us a quick intro about you and kind of what Oasis Labs is doing on a daily.
Yeah, awesome. Thanks, Marco. Really glad to be here to talk about to talk about AI on Oasis Network. I'm Peter. I lead the engineering team at Oasis Labs. Like you mentioned, we're a longtime contributor to the Oasis Network. We've worked really closely with the OPF team since the early days. And so, like you said, a lot of the we've worked very closely together. We're really have been a really important partner together over the history of Oasis Network. On the lab side, we're always looking for opportunities to bring new applications and use cases to Oasis Network, and so that's something that we're is always our focus. We think that right now, there's some use cases in AI that are opening up huge area of opportunity for Oasis Network, and specifically, the kind of the foundation that Oasis Network is built on with trusted execution environments, TEAs, verifiable computing confidentiality. We think we see huge opportunities here in AI, and I think we've got some cool stuff to talk about today. You are muted, Marco.
Thanks a lot. I'm very glad that the differentiation is a bit different to like traditional networks where you have the blockchain, the labs team is kind of the core team. Here we have very unique focuses, and what you guys are doing is serving projects and, as I said, like big corporates with these privacy use cases that sometimes don't even have a need for blockchains, for decentralization. And we have to also be, as an industry, kind of a bit honest with ourselves. Not everyone will be utilizing permissionless networks for their use cases, but we should still try to serve them with the latest in privacy preserving tech, like I know you already did with quite a few big names. But topic today is verifiable AI. You already mentioned, hey, AI is something where we're finally getting together again. It's something that makes lots of sense for decentralization, lots of sense for TEs. Honestly, for me, besides stablecoins, this is the second big use case that is very tangible because it's solving problems that exist in the real world. It's not just building some stuff on top of blockchains that is kind of out of the blue, but solving real stuff that benefits from decentralization, permissionless networks, and also privacy. So AI is already this massive topic, all kinds of subcategories. verifiable AI similarly so. So if you could, can you please define us kind of your perspective on verifiable AI? What does it mean for you? Because from my perspective, it can be verifiable inference. Are we talking about foundational training? Are we talking about privacy, data provenance? What is it?
Yeah. I think that's a great kind of setting the stage for where we think where we think technologies like what we have on Oasis Network can really play a big role. And so, yeah, I would say from our perspective, verifiable AI, it's about providing more information about the AI technology that backs the products and services that people are increasingly relying on. And so, um, and it's about doing it in a way that can be independently verified. And so, without having to, blindly trust the claims that are being made by a developer of a particular service or a model. And so, uh, and also it's really about ensuring that the AI technology that's being so rapidly developed develops in a way that benefits everybody. And so, I think we've certainly seen over the past couple of years as a lot of advancements have happened, a lot of power is being consolidated among a few big players. They might try to buy up all of the available compute power. They might try to slurp up all of our data. And so we see verifiable AI as a way to kind of hopefully level that playing field a bit and allow other players to be able to develop models, develop specialized models, and be able to prove to users what these models actually do, how they were made, and hopefully kind of level the playing field a bit compared to what we have now.
What kind of claims from developers are we talking about? And also kind of just to go back a second, because it does sound again like we are talking about something like ethical AI, but there is quite a difference, right?
Yeah, so I think so when we talk about verifiable AI, we're talking more about kind of the some of the underlying frameworks that we can put in place to allow things about the AI models and about how they're used to be verified. Whereas, I would say I think when you're talking about ethical AI, there's certainly a big overlap, but I would say the techniques that we would propose to be used for verifiable AI are kind of in some way like agnostic to to the particular models or the particular data that's being used. It's basically just saying that um, it would be great to have a way for you as a user that's using some AI backed service or product to know what went into this model, right? And so so it's certainly an enabling technology that I think certainly has a lot of important uses in the kind of AI safety, ethical AI side, where it's a good way to be able to be able to understand what went into a model and some aspects of the model, but yeah, I think we see it more as like techniques and structures that allow those kinds of claims to be verified.
Okay, yeah, fair enough. Who is actually working on this? And I mean, I don't mean in labs, but just like in general in this whole AI vertical market, because I don't see how OpenAI benefits from this. This is kind of their proprietary tech, even in a sense, because they don't want to reveal so much about the actual models. So,
Yeah.
who is currently doing this?
Yeah, it's a good question. Maybe to kind of start, I think you mentioned OpenAI. I think there are a lot of dynamics at play right now, kind of among the OpenAI and the other leaders in the field who are, currently the ones who are, producing these, these foundation models, the really large models that, represent huge investments in terms of, of training and compute to generate them. So we see that, on one hand, we have OpenAI that's it's a closed source. Their model weights are closed source, proprietary, not released. We see a number of other players who are choosing to open source their models and seeing value in that. I think, obviously the big news this week is with DeepSeek R1, which is an open source model or open weights model that's rivaling performance of some of the leading closed weights models as well. So I think, I guess what I'm trying to say is I think we're in a like a transition period right now where there's different, you have different business models and different perspectives on, how open, developers of this technology should be with the technology. So I think one way that verifiable AI can come into play here is that you can potentially have a kind of middle ground between fully open weights where we've released the model and now it's out there, anyone can take it, run it. You're not necessarily able to monetize the usage of that model, right? So once it's out there, you've released it, anyone with the hardware can run it. Or the other side, the completely closed weights thing, where it's like I'm hosting the model, you have to come talk to me over an API to use the model, and you don't really get to see anything under the hood. With verifiable AI, you could kind of have something in between where potentially you could have a model where you're not fully releasing the weights, so it's not fully open weights, but you could have some records about how the model that was produced, how it was trained, or how it was fine-tuned, that are verifiable. So in the experiments that we've done early on, you could essentially have some record that says, okay, we started with this well-known open weights model, and then we did some fine-tuning on it with some other data for a particular purpose. The resulting specialized model, we aren't going to fully release that open weights, but we can prove to you that this is that this is indeed the model that we're running here inside of this T, and you can access that model, and I could potentially you could potentially monetize that without having to just fully release it out there. And so I think I think these kinds of techniques with verifiable AI really it's really a good fit for the current state where it's just there's no consensus on should all models be open, should all models be closed, and so yeah, I think it's quite relevant to this current situation that we're in, where differing opinions on exactly how open things should be.
I mean, but it is fascinating because there is lots of discussion of like open source versus closed source. And just because it's open source doesn't mean it is verifiable in any way. We still don't know any of the data that DeepSeek, for example, was trained on. But it is great to know that, so in theory, OpenAI could release, before they kind of release O2, no one understands the naming anyways, they could release the O1 training data, make it open source, and then just release O2, make it closed source, as currently everything is, and just verify that some for data was used without revealing the data. So that would work.
In theory, yeah. So I think the kind of the thing that I think is most practical to do right now, and what we kind of demonstrated in this blog that we wrote, and talked about these experiments. So what we demonstrated is that it's quite practical and feasible to kind of produce verifiable records of fine tuning that was done on a large model. So a large foundation model, fine tuning for a particular particular specialized purpose. Typically, that involves a relatively small amount of fine tuning training data as compared to the initial pre-training data. Like that's quite digestible and feasible to kind of verify. I think it certainly would be a challenge to say produce some kind of digestible record of all of the data that was used in pre-training a really large model. Not to say it's impossible, but I think I think that's a bit that's a problem that will need some more work to kind of generate something that would really work well there. But again, I think I think we're at a place right now where I know that I'm sure you've heard talk of like we're kind of running up to the limits of the publicly available training data, right? So it's just it's there's only so much data out there on the public internet, and we're really some of these large models are basically training on all of that data now, and so you have these these large general purpose models that are good for a lot of things. But I think a lot of the gains that we'll see now in terms of models that will be better and better at solving important problems will be in specializing these models for particular domains. And yeah, we think that's a really good fit for the verifiable AI work that we've started on.
Yeah, you're giving me the perfect transition from foundational models that should also be verifiable, but then also to confidential compute, because that's when you suddenly unlock proprietary data, because you can verifiably compute or train a model, fine-tune a model on data and not make it public, neither to the end owner or end user, and not to the compute provider. And honestly, this is a massive thing in crypto. And I realized this only like 7 months ago, that this isn't too pertinent in the Web2 space. When, for example, we were at the World AI Summit in Amsterdam like some 6 months ago, and I was talking to Dell and how they provision all of the hardware to their clients, and I was talking about using TEs for confidential compute. I mean, NVIDIA does offer confidential compute, and they didn't get it. They were like, why do I need this? Like, I own the hardware. Why do I need to make sure that the compute was done correctly and in a privacy preserving way? And that's when it clicked, like, yes, of course. If you own all of the hardware, if you have clusters of H100s, then you don't care. But as soon as you start to utilize someone else's hardware, you better make sure that everything is done in a privacy preserving way, and that you have some guarantees for this. So this is kind of also our keyword to start moving into TEs. Which of course is the basis of everything that we do at Oasis. Our network was built on TEs. That's how we achieve on-chain privacy. Yes, this is still on SGX because it's the most robust one. It's been around for a long time. It's more than enough for any kind of on-chain compute. But when you are talking about AI compute, obviously the on-chain world is not suited for, CPUs are not suited for. So that's where people are kind of going towards some combinations of CPUs with NVIDIA confidential compute. So maybe give us your perspective on TEs in this world of verifiable and AI, and I guess confidential compute in general.
Yeah, for sure. Like you mentioned, TEs are kind of the foundation of how we provide the guarantees of confidentiality on the Oasis network with, say, Sapphire, with EVM compatible confidential smart contracts. Like you mentioned, with AI, for both training and inference, it's really not practical to do on a regular CPU. You need GPUs. And so, I think NVIDIA recognized this and developed their confidential computing technology. I think it was exactly the exactly the situation that you mentioned before, where as you make a move to the cloud, you really need some more guarantees about how data is being handled and protected. And so with AI and the use cases that we're starting to see in domains with really sensitive data, so healthcare, for example, these areas where they're regulated and they have very high standards for assurance. They in order to use the cloud, they need a really high degree of assurance that the data is protected, at rest and in use. And so that's where T's with GPU support come in. I think obviously NVIDIA recognized this, and I think that's we certainly agree that this is the direction that a lot of AI use cases will be going, is, like you mentioned, proprietary data, sensitive data. That's where a lot of the gains are going to come with the next generation of AI models. And so for that to really happen, we need GPU enabled Ts.
So why are T so uniquely positioned for this? I mean, I know from like the crypto world, there are lots of attempts even with zkML and things. But also, I mean, obviously from our perspective, we see Ts as the perfect solution. Yes, you will always have this dependency on the hardware provider. So we have to trust, in a sense, even two this time, like the GPU provider, NVIDIA, and the hardware, the CPU provider, which could be AMD, could be Intel. But still, Ts are the best solution. But why do you think so?
Yeah, so there, like you mentioned, there's other there's a whole range of techniques for ensuring the integrity of computations, and also confidential computations that some of them involve, like you mentioned, cryptographic techniques. The real strength of T's is runtime efficiency, so very low overhead compared to some of these other techniques. And so this is actually even more important when you're talking about very expensive computation. And so for training models and for inference as well, these are very expensive computations. And so when you're if you're incurring large overheads there, then that's really going to be prohibitive to to working with the latest state-of-the-art models, either training or fine-tuning them, or doing inference. And that's not to say that there aren't interesting techniques that are utilizing, say, zero knowledge proofs, these things. Like that's there's a lot of promising research in those directions as well. But I think what we would say is today it's already practical to use T's to to fine-tune a foundation model and have a verifiable record of that, and to be able to do inference with that model, and have assurances that your data that you're sending to the model, your queries, are kept private and protected. Like, this is already practical today, and that's what's really cool about T's and the Oasis network, and what we can do now with Raffle and with GPU enabled T's. Like, it's practical to do today.
And that's exactly the main complaint I got when first starting to talk to projects about utilizing Ts for confidential compute. Was always, what's the compute overhead? It sounds like it would be massive, and I simply can't afford it. Like, yes, I would definitely prefer to have some privacy in the compute, but I will not accept like a 50% overhead just to enable Ts on my hardware. But that's exactly kind of why you did the research. So let's dive into it. Like, what was the idea of the research that you did of fine-tuning an LLM in a TE?
Yeah. So I think the main question that we were trying to answer is, can we take a state-of-the-art foundation model And then can we take, the usual, off-the-shelf techniques that people are using to fine-tune these models, and can we do that inside of a T? Like, is it practical to do? Like, can we even do it? Will it, what's the overhead? And so, yeah, that's the question we set out to answer. And so at the time that we coded up these experiments, I think Meta's Llama 3 model was the latest release, and so we use that. I think since then, there's been at least one more iteration released of Llama, but and then the fine-tuning technique we used is low-rank adaptation, or LoRa. This is the standard technique that's used for fine-tuning large models in an efficient way. So this is really, industry standard. And so yeah, we basically just said, can we do this inside of a GPU enabled T? And can we produce, can we produce like a verifiable record of, the inputs, the technique that was applied, and the outputs? And yeah, that's what we kind of wrote up in the blog. So we were talking about overhead. So I think this was a relatively small experiment. So really tiny. It's kind of almost a toy experiment, a tiny fine-tuning data set. And so in this case, I think the runtime overhead was 2x or something, a little bit over 2x. So it was like 12 seconds compared to 25 seconds or something like that. But we would certainly expect this to be smaller with a more realistic, larger fine-tuning data set. And I think in NVIDIA's white paper, the materials that they released with NVIDIA Confidential Compute, I think they were reporting overheads more like, closer to like a 50% runtime overhead for training and a much smaller overhead for inference. And so that's because where the overhead is incurred is really when there's a lot of data being transferred back and forth between the confidential VM and the GPU. That more of that is happening during training than in inference. And so inference time overhead's much smaller. I think they reported around 10% or something on average. So definitely, very, very practical, and something that can easily be can easily be tolerated for the additional guarantees that you're getting.
So how tangible is it for someone that actually already has the hardware to enable their hardware to do so, to do TE compute?
Yeah. So for in order to be able to do NVIDIA confidential compute, you need I believe right now the H100 is the only only widely available GPU that they have that supports it. I think future generations of that chipset will also are expected to support confidential compute. And then you need a processor that supports confidential VM technology like Intel TDX or AMD SEV SMP, which also very common confidential VM technology on server grade chips. And so if you have the hardware configuration that is supported, it's pretty easy to do. So we utilized all open source software to set up the experiments that we ran. I think maybe skipping ahead a bit, but I think now that upcoming, we're expecting full Intel TDX support and ROFL. I think this is something that's really exciting. Will really make it a lot easier to be able to set up this kind of these kind of environments going forward.
Yeah, let's talk about ROFL, because a big problem is it might be easy to set up or to enable, but still you need a way to verify the attestations that you get out of the compute, that you get from the hardware, because just telling everyone, hey, I started the TE, it was computed in the TE, isn't enough. You need a way to also verify this, which is part of the Oasis network. Like lots of the logic revolves around verifying TE attestations and kind of building a system around it that our nodes are running. So yes, Ruffle is a framework that was developed by Yanni, founder of Oasis Network, to unlock off-chain compute with the on-chain world that we had built for many years. Because I think I already mentioned it in the beginning, off-chain compute just brings lots of benefits. It's quicker. You can utilize it for compute-intensive stuff. You can utilize it for privacy-preserving topics. So that's why we built the system. Of course, it is also built with TEs. In our case, we are focusing on Intel TDX. The TDX VMs are really powerful. It's very fascinating to watch what you can run within, because it's just a VM. So in theory, you can run any arbitrary application as long as it can run on a CPU. We have even tried some small LLM models, and it does work. Like, I wouldn't recommend it, but in theory, you can do so. From my perspective, at least, kind of Ruffle benefits are clear, because you get lots of the guarantees from the blockchain that we've built. You have a built-in key management system that is decentralized. You don't have to use any kind of central entity like AWS key management. You have integrity. You have liveness from the actual blockchain. So I assume you agree with most of those, but from your perspective, why would someone utilize then Ruffle in combination with TDX VMs plus the GPU for their off-chain compute or fine-tuning in TEs?
Yeah, for sure. I think certainly agree with all the benefits of Ruffle that you just mentioned. So I think actually back to the previous question that you asked, I think one big benefit is that when we set up this experiment, right, like we had to go configure a confidential VM to be able to talk to the GPU using NVIDIA's confidential computing spec, configure the entire stack that's running inside of that VM. That's something where, like, I think something that would be really cool to see, and I think now will be possible with TDX support in Ruffle, is that you could actually package up this entire stack that runs in this confidential VM, that all of the drivers and the libraries needed to do NVIDIA confidential compute talk to the GPU using that standard. You can package all of that up in a TDX Ruffle application, make it much easier to provision an environment where you could do GPU accelerated confidential compute. And so that's one. Separately, so just to kind of talk about how we used Ruffle in these experiments. And so in these experiments, our confidential VM, or off-chain confidential VM that we used was using a different technology, AMD SEV-SMP technology, which is similar to TDX, but a different platform. And so there, like you mentioned, we have these attestations that are coming from that confidential VM, using their particular attestation format and signature format. Those kind of verifying those attestations is not feasible, practical to do in say an EVM smart contract, right? So it's using a signature scheme that's like it's not practical to verify those signatures in an EVM smart contract. And so if you wanted to bring those records on chain, you need a way to verify that attestation. So we it was really easy for us to go write a simple Raffle app that could verify that attestation, check the signatures, and then if everything matches, post those records on chain. And so that's something where, Raffle makes it really easy to bring, to extend, extend trust to, an off-chain T, even one that's not, natively supported by the platform. And so I think that's also a really nice, it's a really nice demonstration of how Raffle creates this really, flexible, adaptable environment where you can really, choose to extend trust to, arbitrary off-chain T technologies in a way that's fully, fully verifiable on chain.
And actually, one kind of benefit that I keep forgetting, and I don't even know why, because it's so important, because it's about interoperability and composability, is that Raffle is essentially off-chain. Yes, it's registered on-chain. It does have quite a bit of connections to our chain because it benefits from it, but the whole compute happens off-chain. So it's so easy to do, for example, even RPC calls into other networks. So you don't always have to go back to the on-chain world, then kind of pass messages to other networks. Just like keeping it off-chain but still verifiable is incredibly powerful, and I'm really excited to see more utilization of it. But before we dive kind of too deep into Raffle, if you could give us a quick kind of summary of the research, or rather the research findings, just to kind of conclude with that topic.
Yeah, sure. So I mean, I think the main findings were, as I mentioned earlier, it's practical as of today to take basically a state-of-the-art foundation model, open weights foundation model, to fine-tune it for a specialized purpose inside of a GPU-enabled T, and produce a digestible, verifiable record of the fine-tuning that was done to that model, and to publish that on chain in a way that could be utilized by. I don't think this has come up yet, but I think one of the things that we're most excited about with the combination of decentralization and AI is on-chain, decentralized marketplaces for AI models and services. And so for that to work, you need to be able to have publish on chain some information about the models, and about the more information the better about how they were constructed, right? And so I think the main finding from these experiments is that all of the pieces are there for that to really be possible as of today. And so I think we're excited to see these kinds of applications, and hopefully marketplaces like this start to be developed on the Oasis network, because all the pieces are there. And that's the main finding.
Okay, perfect. And you wouldn't believe how often I'm talking to projects, and in the initial call, they pitch it as on-chain Hugging Face. So definitely quite a bit of need for these decentralized marketplaces. And we are always happy to support those projects. One more benefit, we were talking lots about foundational models, but in kind of the application side of things, people are just utilizing APIs. So most of the projects, they don't even need any GPUs, because they just get their inference from OpenAI, Claude, it doesn't matter. But obviously, they still benefit greatly from TEs, because what you do is you run the whole application in a TDX VM. And what you can do with this is guarantee to your users that the output actually comes from the API. So yes, your users do need to trust the API, but they don't need to trust you. They don't need to trust that you are not messing with the agent output, that you're kind of controlling the user funds even, because we're currently moving away from these meme agents where this really didn't matter. It was just fun and gimmicky, and I didn't care who is in control of this or who is sitting behind it. But now with DeFi agents, where they are controlling user funds, they are moving those user funds. I want to make sure that this is not custodian. Like, this needs to be trustless, this needs to be unruggable, and this is definitely something where Ruffle comes into play, because what you can do is have the whole application containerized, spin it up in a Ruffle TDX VM. You even create the private key in the Ruffle app, so there's no way for anyone to kind of control the agent. And then you let it loose on DeFi protocols, see what your agent does. It's still going to be fun. It's still going to be unpredictable, especially if they are still powered by LLMs. I'm sure we will be moving also more towards math models, specifically in the DeFi space. Like, LLMs can't be doing too much, I assume, but that's to be seen. I saw we already had quite a few questions. I do want to pick up a few before we kind of continue. For example, regarding your research and experiment, are you making the code for the experiments available?
Yeah, we certainly we expect to make the code available in the near future. So yeah, stay tuned for that. We plan to publish the code.
Okay. When you do, we will also be posting about it. So as long as people are tuned to our socials, they will see it. Another one, great news. But who is using this tech? Which AI companies are adopting?
Yeah, I mean, I don't know. That's one that maybe I can throw back over to you, Marco, as the head of AI at OPF. Like, we've been kind of focused on just doing these experiments about kind of technical feasibility and getting being able to show that things are ready. If I had to, if I had to speculate on the kinds of use cases where this technology will be most in demand, I would think it's going to where we mentioned before about places where there's proprietary data, highly sensitive data. And so a domain that we have worked in a lot on the Oasis Lab side and have focused on a lot is in the healthcare space and with health data. And so that's one that we are particularly interested in, and where we think there's a lot of potential. I'd be curious, Marco, from your side, where you're hearing the most kind of interest in bringing AI, bringing decentralization to AI.
Definitely on the fine-tuning on proprietary data, because there is this bulk of people sitting on some data that they do not want to share with any compute provider or anyone in general. But they do want to have their own custom model that they can then kind of utilize in their own applications for whatever reasons. Another one, and that's more on the privacy side of things, is private chatbots. I simply want to be able to talk to LLMs without sharing everything with OpenAI. Like, even me personally, I use it daily for pretty much everything, and I have already shared a lot about myself. And it's honestly scary, because there have been in the past these leaks where there's a leak of emails and all the prompts that are connected to this email. And if I just consider this being released today from OpenAI, because I ask it all kinds of things about my life, relationship problems I have, just to kind of get a new perspective, someone that's outside, that doesn't have a strong opinion, just to kind of pick my brain on it. So yeah, that's a big one, and we have lots of projects currently just waiting for us to enable GPU support, because they do need the GPU part. Because if you still utilize an API, then the whole kind of story of private inference is lost. So that's a big one. And then, of course, all of these agent projects, but at least in this current phase, they are fine with CPUs. So we're already offering them deployment of Ruffle apps, because it can be TDX VMs. We have quite a few TDX machines ourselves. It's rather straightforward to spin up these VMs. And currently, we're just focusing on making it very easy to build these Ruffle apps. Pretty much just have your Docker compose .yaml file, and we will host the Ruffle app for you. And then it's out in the wild and running, and it's verifiably private. But of course, yes, it is running on CPUs. So yeah, it's generally these 3 use cases that are currently talking, or projects with these 3 use cases that are talking to us and that are just excited to try it out, because it doesn't work anywhere else. You need this TE cloud, and that's why we are also working full speed on the GPU support, specifically with the H100s. Great. I'll take another one. What challenges, if any, were discovered during experimentation help to shape Oasis Network's 2025 roadmap?
Yeah, so to kind of think about challenges, so what are the current limitations? So first, I think the configuration that we were using, based on what kind of the open source stack that we're using out there, the open source libraries for using NVIDIA confidential compute, and the documentation we could find. Currently, we ran into some issues trying to utilize more than one of the GPU GPCs to kind of do parallel training, right? So it's certainly something that's supposed to be possible. I think there may have been some NVIDIA confidential compute. The libraries and technology is still pretty early, and so basically we were limited to using a single GPC of the H100, which I believe has 8 on board, and so that kind of limits the size of a model that you could do fine tuning of with a single confidential VM. That's something that I think, if not already fixed, will likely be fixed soon on the side of those libraries. I think, like, thinking about Oasis Network's 2025 roadmap and where I would like to see things going over the next year, I think back to what we mentioned before about the power of being able to package up the entire stack associated with doing training or inference as a confidential VM that can connect to an H100 GPU. It's like being able to package all of that up as a TDX based ROFL application and deploy that would really be a game changer, I think. So we certainly don't expect that any application developer out there who would like to use verifiable AI in their application, they shouldn't have to go through this whole the whole steps that we did in this experiment of provisioning a custom confidential VM and being able to write a ROFL app to validate those attestations. That's definitely too much burden for an application developer. And so that's where like you mentioned, Marco, that's where ROFL's going with TDX support, and TDX plus GPUs is just the natural next step. And I think that'll be a real game changer, and that's I think definitely within sight.
Yeah, it's always mind-blowing when I just consider, hey, the whole application of some projects could be running in a TDX ROFL, where I'm just thinking about, hey, you utilize it to verify that the output is coming from a specific source. But no, the whole application can be running there to have trustless software in a sense. And I'm glad that you mentioned the limitations also from NVIDIA's tooling. This was another aha moment for me, where I was like, we are very early. Confidential compute wasn't here before the Hopper series, and multi-GPU attestations weren't released until I think September, August last year. At least that's when I kind of first started reading into it, and it's still not very easy to utilize. So yeah, It's going to take a while until even the tech catches up. But fortunately, the application side is pushing. Lots of people are kind of utilizing it. I'm looking at the questions. Code will be available. We will share it. What LLM framework are people using in Ruffle apps? It doesn't matter. They can use whatever they want. We don't give any limitations there.
Yeah, I think that's right. And just to, I think in our experiments they demonstrated this pretty well. Like I think we mostly used popular Hugging Face libraries to do the fine tuning, to do inference. Like, so yeah, I think that was also a finding, is that you can just take your whatever your favorite framework that you're using before, and doesn't just kind of will work out of the box, which is awesome.
Right. And I kind of forgot to give my perspective on the previous question about our 2025 roadmap.
Yeah.
Our big takeaway from last year was definitely we need to provide more than just the basics, because we always focus on decentralization, security, and we are like, hey, it's secure, it's decentralized, here, use it. But it's not enough. We realize, hey, we need to make it as easy as possible from a DevX to be able to build, to be able to deploy, and then from also a user or anyone that wants to perspective to verify. And that's what we are now really stepping up with Ruffle. I don't know if you saw our Monday engineering demo. Yanne presented his latest on the Ruffle development, and it's so easy to just build these Ruffle apps from containers. So I'm quite excited to have the repo hopefully soon public and share it with everybody so that people can try it out. But yes, for us, it's definitely a focus on DevX, because with just the primitives, it's very hard to get like regular teams to adopt the network.
Yeah, for sure. And just to piggyback on that, I think, as someone who's, been, working as a contributor to Oasis Network since the very early days, I think, like you mentioned, kind of in our DNA is to build things that are secure, rock solid from the ground up. And that's awesome. And that's been a real, that's been, part of our foundation from the beginning. And that's, we're at a point now with, obviously, we reached with Sapphire, a while back, where, okay, all of the foundation is here. Now let's focus on the developer experience, make it easier for developers to use. Like we went through that with Sapphire. That's happening with Ruffle right now, right? And so, I think, the sequence has always been build something that's secure, rock solid, and then, then make it, easy to use for developers. And yeah, I'm very excited to see that happening in the next year with Ruffle.
And people are quick to be impatient. They're like, hey, when GPU support, when this and that. But it takes time if you want to have a full-fledged release that it has been tested, that is secure, and that we are happy with. There are, of course, standards. I saw another question. So are the Ruffle apps in Rust communicating with the shell environment to access services like Ollama while all inside a confidential VM?
Yes, I think maybe there's a bit of, we're conflating a couple things there, right? So I think with Ruffle apps and Rust, we're probably talking about SGX-based Ruffle apps, which are, not a complete confidential VM, but it's just a SGX enclave binary. So that that's one type of Ruffle app, and then the the newer type of Ruffle app with TDX support, you can have an entire confidential VM, an entire stack running there.
Okay. I do have one more question, and it's a bit of a general one. I'm just curious about your perspective on the whole AI landscape these days. Like, as you said, DeepSeek
R1, yeah.
DeepSeek, they came out very recently, kind of shook up the world with claims about very cheap fine-tuning. Now or actually foundation model, sorry. And now my tweet is full of claims, hey, they just kind of ripped off on OpenAI. They maybe used more compute. It's going crazy, but from my perspective, at least, I'm very excited about it because at least if you trust the claims, it would unlock quite a new world for foundational model development. And since it does seem to go towards smaller models, I feel like the demand for user or consumer GPUs that can run models and that way achieve private inference will also increase. So there's lots of venues for kind of improvements of the current state, but that's just kind of my 2 cents. But happy to hear your thoughts on what happened in the past few weeks and months.
Yeah. Yeah. So again, it's an exciting time, and so I think you said, you find it exciting. I think to me, it's just all of these developments are opening up more opportunities, right? And so I think if we think about, go back and think about kind of the vision and the mission of Oasis Network from day one, which is, allowing users to have more control over their data, how their data is used, within other applications and services that they're using. I think any of these trends toward more powerful models being able to run on, less beefy hardware is cool, because that means, you can potentially do more things locally. You could have, you could be doing more of the computation locally, which is always good. But I think, I certainly don't think there's no reason to believe that like we'll be able to bring everything to the edge, and now all of the AI technology that you're going to need is all going to be running on your local device. Like I think that's unlikely to be the case. And so there's always, I think we're going to continue to see this kind of heterogeneous environment where you'll be potentially running some models locally on your phone or on your laptop, which is cool. And then when you need other capabilities that those models can't handle, it's going to need to run remotely. And so that's where that's where T's come in, right? And so you can basically get those same kind of guarantees that you're getting with these local models, where my data is never leaving my device. So that's great. You can kind of get a similar guarantee to say, well, this is a model that's running out there in the cloud somewhere, but it's running in a T, and I can be assured that that my data is not going to leak. Like, I think the kind of like end vision that we would see, that 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 we would like to see, is something where like you have this kind of heterogeneous system where your local model is handling some things, a model in the cloud running in a T is handling some things. And I think kind of orchestrating that will be an interesting problem that will need to be solved. But like uh, a blockchain like Oasis that has native support for confidentiality is like really well positioned to help help be a part and help be involved in all of that orchestration as well. So I think all of these developments only serve to kind of further strengthen our belief that that T's will play an important role in in AI going forward, and that the Oasis network is really an ideal platform to build this kind of thing on.
Oh, these were so perfect closing words. I almost feel ashamed asking you one more question, but I do have one, because despite all the excitement about AI, it is also very scary. I personally have lots of concerns about how society will handle any arrival of AGI. Don't even want to think about ASI. But before I come to the big question, I do want to hear your thoughts on verifiable AI and how it's bringing us potentially closer on solving the alignment problem, because it goes in the right direction, but it's still quite complex.
Yeah, I mean, like you mentioned, those are big problems. I think the more so if you're if we're thinking about safety and about putting in, potentially putting in safeguards and having the ability to, to kind of uh, to kind of look at where things are developing and potentially, pause something that that is that's seen as risky, or exhibits some problem. Like, I think verifiable AI is an important part of that, right? Because you really, knowing more about a particular model, about, how it was developed, how it was constructed, all of that, makes it easier to be able to kind of identify something that's a problem, and then potentially identify the chain of like derived models that came from that, and be able to say, this is this is a risk that needs to be contained. So I think that can help. Uh, Also, there's still a lot of problems to be solved in terms of like, um, from the alignment perspective. Like, I think, um, it is useful to know what went into a model, what training data went into it, and so that helps. But there's still a lot of interesting research problems beyond that to say, you know to solve the alignment problem and the safety problem. So yeah, I don't know, maybe not a not a not a really complete answer, but just to say that, like, the kinds of things that verifiable AI can help help you determine about models will certainly be valuable in helping solve these problems.
Yeah, exactly. I don't think there is a complete answer. I was reaching a lot, but I definitely do agree that this is a step in the right direction, and definitely something that should be encouraged by more. I hinted at the big question. My big question is always, when I talk to AI experts or anyone working in the field, what is your PDoom?
Oh, uh, you know, I I don't have a PDoom off the top of my head. I would say that uh, I would say how can I just say this? I'd say I'm more of a an optimist than a doomer here. I think that just my intuition is that we're with the current techniques and the current technology, and the way that the way that advancements are being made currently, it doesn't feel to me like this is a path toward doom, because I still think the most uh, the way that the the way that these models are most powerful and most effectively used is still as a tool, right? And enhancing the capabilities of, for me as a software engineer, enhancing the capabilities of a human programmer who is looking to be more efficient and develop better code. Really helpful at that. Helpful for people, other writers, composing composing writing as well. Like, I think these are the places where they're you know the models are most powerful. I do think the kind of the next generation models you hinted at with reasoning, right? So reasoning models are the next frontier. And if I if we see I think it's just a really interesting transition time. And I think if we see the kinds of advancements in reasoning models that we saw early on with generative models a few years ago, then maybe my PDoom goes up pretty quickly. But right now I'm still very optimistic about really the ability of AI technology to really enhance what we can do, and how productive that we can be, and the kinds of things that we can accomplish. And yeah, I think there's huge, really huge potential there.
That's a great answer. I have to agree. My PDUM currently is also rather low. I do consider it an amazing tool. I would recommend anyone to just keep talking to LLMs, try out the latest models, check out how does the reasoning currently work, maybe utilize the APIs in a couple of setups, have some discussions between LLMs, shoot APIs against each other, just kind of see how it currently works, what the level is, where they struggle, because I think that's important to realize also the limitations of them today. They might seem incredibly intelligent, but then at the stupidest things, they run into these loops and you can't get them out of it. But yes, they are tools and we should be using them. I think we definitely have discussed a lot. We also ran a bit over time. I am sorry for that. If you're missing some meetings, I know your day is just starting, while mine is running or getting towards the end. We discussed Oasis, we discussed Verifiable AI, we discussed the latest framework that we have released, which is Ruffle, which unlocks some really powerful use cases. It's also very unique in the off-chain compute or TE cloud sense of things, because it does still utilize our network that we have built over many years and brings benefits like decentralized key management, even some MPC protocols that we have embedded. It brings integrity, some sense of time for the application. So all kinds of exciting things on the horizon. I'm really excited to finally release also some more documentation about the TDX, things that Yanne has been building, to finally also showcase some more applications that are currently building with us, or those that are currently waiting for us to release the docs to be able to start building. So lots of cool stuff happening. I am really bullish on the whole decentralized AI narrative, likewise on the verifiable AI narrative, which I think more and more people should be looking at. And it's a great time to be in crypto and in TEs.
Great way to end it. Yeah, it's a lot of fun, Marco. Thanks. Thanks so much for having me. Fun discussion. And yeah, like I said, I'm just really excited to see where Oasis Network goes in 2025, especially with Ruffle. A lot to be excited about.
It's going to be fun. Thanks a lot.
Awesome. Thanks, Marco.
Bye, everyone.